Hello. Just tell me what you have written for this first part. Go ahead. Good. For the second term, go ahead. For the second part, question number second. Okay. Just see in this part, we have two significant figure after decimal in this first part, one significant figure after decimal in this part, and three significant figure after decimal in this part. So we have to answer in terms of lowest significant figure after decimal while adding, subtracting. So which of these having smaller or minimum number of significant figure after decimal? So you will say in this second part, which having only one significant figure after decimal. So your answer should be option number C. Is it clear? Next is distance covered by the body is this much, and you have to find velocity. How you have calculated? You have to just differentiate it. So on differentiating, velocity will be equals to 60 square minus of 60 plus 4. So on putting the value of t to be 2 seconds, it will be 6 into 4, 24, 6 into 2, 12 plus 4. 24 minus 12, it will be 12 plus 4, it will be 16 meter per second. Option A is correct. Next is question number 4. You have to calculate average speed. Good. Question number 5. Since it is going along this direction, let's say this is your ground. At any instant, halfway in its path, its velocity is 10 meter per second. At highest point, its velocity will be 0. And from this point to this point, displacement will be h by 2. So just use third equation of motion. V square equals to u square minus of 2 gravity into height. So it will be this 2 and this 2 will cancel out. 10 into H is equals to 100. So H will be just 10 meter. Good. Let me check. I had already defined you these segments in projectile motion. Okay. So do you have any doubt from last class? Schwab? There will be some question related to this pressure in terms of YouTube. Suppose like this, and there will be liquid inside. One will be till this part, and the other will be till this. And next, in this arm, it will be till this part. So for this type of problem, just draw a horizontal line from its lowest point or lowest junction. So in this part, it will be along this line. As I had defined you in last class about or related to Pascal's law at same horizontal level, let's say point A and point B, pressure will be always equal. Is it clear? So you'll say pressure at A equals to pressure at B. This is liquid first having density ρ1, liquid second having density ρ2, and liquid third having density root 3. Level of this liquid will be H1, H2, and H3. So pressure at point A will be absolute pressure due to air plus this particular liquid. So it will be P naught plus rho GH. Pressure at point B will be due to atmospheric pressure due to liquid first and liquid third as well. Now on putting all the values of rho 1, rho 2, H1, H2, you will get the unknown part from this expression. Is it clear? So for any YouTube problem, just draw horizontal line from the lowest junction and then pressure at this horizontal level on either arm should be equal. Pressure at same horizontal level on either arm should be equal. Is it clear, Vahid? Okay. Just write it down. You have written? Similarly, there will be another problem. Suppose there is a container like this in which liquid is filled up to this level. Now it is accelerated along horizontal direction. By some acceleration A. How will the level of liquid in this particular container will change, or in which direction it will get uplifted or raised? If this container is accelerated horizontally by some acceleration A, so in which direction liquid get raised up. Abdul Wahid, you will say, since this particular container is horizontally accelerated, so the level of liquid would change like this. So if you draw a horizontal line at this, having inclination theta, so this A will be equals to G times tan theta, or this is perpendicular and this is base. So this theta will be equals to perpendicular divided by base. Is it clear? Okay, just write it down. You have written? So this is about pressure, Pascal's law till this point. Let's start new topic. Surface tension. For this, I will define you first about molecular interaction. There are two different types of molecular interaction. First is called adhesive and second is called cohesive. Adhesive means attraction between similar molecule or same type of particle. So adhesive means attraction between, oh, just 1 minute. For adhesive, it will be attraction between different particles. Or different molecule. But for cohesive, it will be attraction between similar particle. Is it clear? Suppose there is a container filled with any liquid. Let me assume different segment. Let's say at this lowest point, there will be a particle at center which may be attracted from its all neighboring particle due to cohesive force. So one along this, like this. So the net force on the centralmost particle due to all its interaction or cohesive interaction will be zero. Is it clear? Similarly, if you suppose at its highest point, let's say at this point for any particle, so for this top layer, there is interaction of the centralmost particle along this direction only, since there is no any particle above it. So in this part, the net force on the centralmost particle will not be equals to zero. So you can say the top layer of liquid surface get attracted or slightly stretched due to molecular interaction. This property of top layer of liquid film is termed as surface tension. Is it clear? Okay, let me describe once more. I have taken a particle well inside at this particular point and define its all interaction with its neighboring particle. So these are its all neighboring particle, and this interaction is cohesive interaction. But for this top layered liquid, there is force only towards downward direction or outward direction. So this top layered liquid or thin film will tend to behave as a stretched membrane due to its molecular interaction with neighboring particle. This stretched behavior of this top layered liquid is called surface tension. Is it clear? Abdul Wahid? So we can define it like the top layer of liquid behaves as stretched membrane due to molecular interaction. This property is called surface tension. Okay, first write it down till this part. Abdul Wahid, you have written? Okay. Now, on the basis of this molecular interaction, we may define surface tension in some other way. First, surface tension acts between interface of any two separating medium. So it acts or it defines it acts tangentially at the interface of two separating medium. Next, surface tension will be proportional with cohesive force. Greater the value of cohesive force, it will have more surface tension, and inversely proportional adhesive force, inversely proportional to temperature, inversely proportional to impurity added, or surface tension decreases on adding impurity to that particular substance. It defines you the spreading tendency of liquid. So surface tension is inversely proportional to spreading tendency of that particular liquid over that particular surface. It means smaller the value of surface tension, it will have more spreading tendency over that particular surface. Is it clear? First, write it down. I'm giving you some example related to these terms. Wahid, you have written? Okay. Due to this temperature dependency, at boiling point of liquid, surface tension equals to 0. Next, if you drop liquid on a surface and mercury on the same surface, the shape of liquid would be like this in case of water, but in case of mercury, it will be like this. It means particles of mercury have stronger cohesive force as compared to adhesive force. That's why they remain in combined state or remain in spherical part. But for water molecule, adhesive force is more stronger as compared to the cohesive, so it gets spread out. On an other way, you will say surface tension in water is smaller. That's why it have tendency to spread out over that particular surface. But for mercury, surface tension is large enough so that it remain coagulated to spherical shape. Is it clear? So this is in case of water on a surface, and this is mercury on that particular part. So we can define surface tension tangentially to this particular point. So it will be along this direction, along this direction, and along this direction as well. So this is between solid and liquid. So it will be termed as solid and liquid. This is between liquid and air, and this is between solid and air. So at this point, it have mainly three different interaction or three different interacting medium. Similarly, for this shape, one will be tangential to this between liquid and air. The other is along this direction between solid and air. And the other is along this direction between solid and liquid. Is it clear? This T is called surface tension for that interacting interface. Wahid, is it clear? So if you define angle in these two different surface tension at this point or at this point, this angle is called angle of contact. So you may define angle of contact in two different parts. If it is acute, which means adhesive force is more stronger as cohesive force, and if it is obtuse, it means cohesive force is stronger as compared to adhesive force. Or in terms of surface tension, if theta is small, it will have smaller surface tension, or if theta is obtuse, it will have larger value of surface tension. Is it clear? Wahid, any doubt? Okay. You have written till this? Now, there would be some theoretical question related to this. First, why we prefer hot soup rather than cold. Next is why we use detergents along with water to wash clothes. why some insects able to walk on surface of water So let me define you each individually. First, why you prefer hot soup instead of cold? So it will be for hot soup, temperature will be more, which means surface tension of that particular soup will be smaller. And smaller the value of surface tension, it will have tendency to spread out to more surface area. And since our tongue consists of different taste buds at a different region, so soup will reach up to maximum taste buds, so it will feel better. Is it clear? Or it will taste better? Wahid, is it clear? So first is, why do you prefer hot soup instead of cold? So you'll say, if temperature is more, surface tension will be less, so it can easily spread on tongue to reach maximum taste buds. So can taste better. Similarly, in the second part, why do we use detergent along with water to wash clothes? So you'll say, on adding detergent to water decreases its surface tension. So it will have tendency to spread out on more surface of oil and grease or dirt, so that to clean it more accurately or proficiently. So you'll say, on adding detergents decreases the surface tension of water, so can easily spread out over dirt to clean it up. Similarly, why some insects able to walk on the surface of water? So it will be due to surface tension, which can balance its weight. Is it clear? Wahid, any doubt? Okay, just write it down. You have written? Abdul Wahid? Okay. Now let me define you how to calculate numerically the value of surface tension. Suppose you have a disk like this. Just 1 minute, I'm coming. Okay. Abdul Wahid, are there? Okay. Suppose there is a hollow disk, which means inner radius is small r and outer radius is capital R, and it is placed over liquid. So if you have to raise this disk from the surface of liquid, so you must have to apply first a force equals to weight of this particular object, and the second, the extra amount of force, which will be to overcome the interaction of liquid with its surface. That is due to the adhesive interaction, or you can call it as due to surface tension. So the extra amount of force must be applied over this particular body will be to overcome this particular surface tension. And it will be equals to force divided by length of interacting boundary. So T is surface tension, F is the extra amount of force beyond or above that weight of body, divided by length of its interacting boundary. So force per unit length is called surface tension. The unit of force is Newton and length is meter. So its SI unit will be Newton per meter. So now let me define you formula for calculation of surface tension for this part. So it will be equals to force divided by length of its interacting boundary. So one inside and the other outside. So it will be F divided by 2 pi to be common is equals to this part. Is it clear? Wahid, is it clear? Now, if you shrink or decrease the width of this particular ring or disk, it will be like this or form a ring. This is hollow disk. Now, this is ring in which small r equals to capital R. So surface tension equals to force divided by r plus r to r. So it will be 4 pi r. Now, if you further break it to form a rod or for a straight path like this, so 2 pi r becomes L. So this will be L plus L. So surface tension equals to F by 2 times of L. And one last part for complete disk. R will be 0. So surface tension equals to F divided by just 2 pi R only. Is it clear? Okay, just write it down. Abdul Wahid, you have written? Okay. Now there will be question related to these terms. If surface tension of liquid is 0.07 Newton per meter. Find extra must be applied to uplift a rod of 1 centimeter. Just use the above formula and try to calculate. You have the value of surface tension as 0.07 Newton per meter. Length of wire is 1 centimeter. You may write it as 10 to the power minus 2 meter. Just use the above formula for rod and simplify it to calculate the extra amount of force. Try to solve. Abdul Wahid, just see, we have surface tension and length. So according to the formula, surface tension equals to force divided by 2 times of L. So force will be equals to 2 times of L into T. On putting all the values, 2 into 10 to the power minus 2 into surface tension 0.07. So just, it will be 10 to the power 2. 7 into 2, it will be 14 into 10 to the power minus 4, or 1.4 into 10 to the power minus 3 Newton. Is it clear? Abdul Wahid, you have written? Okay. Now the next topic is energy to form, drop, or bubble. So work done equals to force times displacement. Suppose there is a drop having radius r to this point, and if you have to increase its radius to this, so change in radius will be delta r. So work done to expand from this initial point to this final point, it will be force times delta r. Force is surface tension into length times delta r. Length into breadth is called area. So you may write it as P delta A is equals to work done or equals to energy. Is it clear? Now to use this formula, let me define you the concept of surface or interacting surface. In case of bubble or in case of drop, in this drop, there is only one surface exposed to air. So you will say interacting surface in this case will be 1. In second part, for the case of bubble, there is two different surfaces getting interacted to air. One would be from inside and the other is from outside. So interacting surface in this case will be 2. Depending upon these interacting surfaces, which may define energy equals to surface tension times area, and for this part it will be surface tension times twice change its area. Is it clear? Okay, just write it down. Abdul Wahid, you have written? Now, there will be a question related to this. Find work done to increase the radius of bubble having surface tension 0.05 from 1 centimeter to 3 centimeter. Suppose there is a bubble initially of radius 1 centimeter. So we have to calculate amount of work done to increase its radius to 3 centimeter, like this. Initially it was till this. Now initial radius is 1 centimeter, which is equals to -2 meter. Final radius is 3 centimeter -2 meter. So first we have to calculate change in its surface area. As area of a sphere is equals to 4 pi r squared. Initially, it will have 4 pi small r squared. Take out 4 pi as constant. Put the value of capital R to be 3. So it will become 9 into 10 to the power -4 minus 10 to the power -4. So you'll get 8 into 4, 32 pi into 10 to the power -4 meters squared. Abdul Wahid, is it clear? Now, according to the above formula for bubble, amount of work done will be equals to 2 times surface tension into change in its area. 2, surface tension is 0.05 Newton per meter times change in surface area 32 pi into 10 to the power -4. On removing decimal, it will be 10 to the power +2. And on simplifying further, 2 into 5, 10 into 32. So these two terms will cancel out one of its power. So you're left with 32 pi into 10 to the power -5 joule equals to net work done. Is it clear? Wahid, do you have any doubt? Just write it down. Wahid, you have written? Now, the next concept will be combination of drops. Suppose you have n number of drops like this, each having a radius small r. On combining, it will form a single large drop like this. So you'll be asked first question, which of these two combination will have larger energy? So you will say the smaller the body is, it will have more surface area exposed to air. It means it will have greater amount of energy. It means these small drops will have larger energy as compared to this combined part. So on going from left to right for combination, this particular reaction will be exothermic. Is it clear? So you will be asked to calculate change its energy on combination of drop. So let me define you how to solve it. We have first, since smaller drop will have larger surface area exposed, so it will have more energy. Next is volume on either side of the liquid will be same. So volume initial should be equals to volume final. Each drop is spherical in shape, having volume 4 by 3 pi r cube, and there are n number of drops, so it will be n times 4 by 3 pi r cube. For a single large drop, it will have 4 by 3 pi capital R cube. So 4 by 3 pi, 4 by 3 pi cancel out. So you will get R equals to n to the power 1/3 times small r. Is it clear, Abdul Wahid? Now, to calculate surface area, change in surface area equals to n number of drops, each having surface area 4 pi r square minus surface area of larger drop equals to this term. So if you put the value of capital R to be this term or small r using this expression in this, you will get a relation in single term. And then multiply it by surface tension to calculate amount of energy evolved during this process. So it will be T times delta A equals to T, 4 pi is constant, keep it outside, n times small r square minus capital R square. So this will be the total amount of energy evolved during this process. Is it clear? Just write it down. Wahid, you have written? Okay. Now the next question will be about pressure difference, which may be called excess pressure. Suppose you have surface like this. So if you define tangent along this direction, T, and for this path, it will be along this direction as T, as surface tension acts tangentially. So if you draw a vertical line and a horizontal line to this part, take this particular angle to be theta, theta. So there will be two components of tension related to this particular theta. One would be along this direction, T cos theta, and the other will be along this direction, T times sine theta. Similarly, for this part, it will be T cos theta, and the other will be along this direction as T sine theta. The other thing will be there will be pressure from outside like this, and the pressure from inside, it will be like this. So you will say in equilibrium, pressure inside equals to pressure outside plus pressure due to 2t sine theta. So if you have to compare this part and this part only, you will say pressure from inside is greater from outside by this much amount, which means from inside it will be towards concave side, and from outside it will be towards convex side. So pressure towards concave side is always greater than pressure towards convex side. So you may be asked, in which of the two faces pressure will be more? So just remember, pressure on concave side will be greater than convex side. Is it clear? Abdul Wahid? Just write it down till this part. Wahid, you have written? So we have to calculate this excess pressure from inside and outside. So let me define you how to calculate it. Suppose there is a drop whose initial radius is r. Due to pressure difference, it gets slightly increased by delta r till this point. This is r and this is delta r. Pressure inside is Pi and pressure outside is P naught. Consider a drop having radius r is increasing or expanding due to pressure difference. So work done equals to force times displacement. I have taken force in terms of surface tension first case. So it will be TL times delta R. So it will be T times delta A. Now, if you calculate surface area or change in surface area for this part, delta A equals to 4 pi outer radius square minus 4 pi inner radius square. Take out 4 pi as common and expand it. You'll get a square plus b square plus 2ab minus r square. So this part and this part will cancel out. This is square of very small term which may be neglected. So we're left with only this part. On multiplying with this, you will get P times 8 pi r delta r as equation first. Is it clear? How I have got this result for work done? Wahid, is it clear? Just write it down. Wahid, you have written? Okay. So in next part, we can write related to pressure. So again, work done is equals to force times displacement. Force is equals to net pressure into area of cross section into displacement. Net pressure is Pi minus P naught into area of cross section. That will be area of sphere at this instant. So it will be 4 pi r square times delta r. So this will be equation second. And now, since these two equations are for same work done, so they must be equal to each other. So on combining these two terms, we can write from equation first and second, Pi minus P naught times 4 pi r square delta r equals to T times 8 pi r delta r. So on cancelling out similar term, you will get Pi minus P naught is equals to 2T by R. So this will be your pressure difference due to surface tension for drop. Similarly, in terms of bubble, which having two different interacting faces or surfaces, Pi minus P naught equals to 4 times T divided by R. Just write it down. Wahid, you have any doubt till this part? Okay. You have written? Okay. Shoaib, you have written? Wahid? You have written? Okay. Now, in this part, since pressure difference is inversely proportional to radius, so smaller the bubble, it will have more amount of pressure difference. And this pressure difference is also termed as gauge pressure, which we have already defined in last class. Now, on the application of this part, or just stop here. In next class, I will continue after it about Asian formula, and then we'll start with hydrodynamics, that is fluid in motion. Okay, so let's stop till this part. Abdul Wahid, do you have any doubt from today's class? Okay, then we'll meet in next class. Okay. Allah Hafiz.